So let us continue. In the previous session, we have got the following. For X bar chart, for R chart, we have got these values. X bar is equal to 6.2912. UCL is 6.4645. LCL is 6.1178. For R chart, we have got R bar as 1.1328. UCL we have got as 1.7456, and LCL we have got 0.5199. Now, drawing of this particular statistical quality control is very simple. What you are going to do is that, first of all, you draw a vertical axis of this kind. Then you select a point. Say, for example, this, your, the point 6.292. Suppose this is your 6.2912. Okay, and suppose this is your 6. This value is your 6. Okay, so you just calculate, you just measure and move upward and find approximately the point which is 6.46 approximately, and below somewhere you find your point. Say, for example, this if this is 6, then suppose this point is 6.11, 6.118, 6.1178. I'm doing it very roughly because I do not have the graph paper. In graph paper, we will be having the origin, and from there you are going to select appropriately 6, all these points, 6.2, 6.46, all these points has to be appropriately chosen in the graph paper. So if you are doing statistical quality control problems in examination, so, and if the graph papers are not provided, then you just ask for the graph paper. So this is your line, this is your UCL line. This is your center line. And that is your LCL line. Okay, and now after correctly putting these lines, what you have to do is that you have to plot all these points. You have to plot all the points given. You have to plot all the points given in the question accordingly. So say, for example, the first point is set 5.5, so it will fall below somewhere over here. So if this is 5, so 5.5 means this one, so that will be your first point. So you are going to draw a dot like this. Your second point is 5.39, so a dot like this, and in this way you can plot all the points. Next point was 6.85, so that is above UCL, so you are going to do it like this, and then you have 6.75, so you are going to do it like that, and then 5.83, you are going to do it like that. Okay, 7.22, you are going to do it like that, and so in this manner you can plot all the points. Now if I plot the points right now in over here, then that will be just it will just kill time. I'm just asking you that how to plot the points. Okay, so say, for example, this is your first point, this is your second point, that is your third point, that is your fourth point, that is your fifth point, that is your sixth point. Okay, let me 6.39, that is another point which is falling inside. So 6.39 is somewhere here. So that is your next point. 6.55 somewhere here. 6.55 somewhere here. So that is another point. Then we have 7.15, another, like this. So we have several points, and after that what you need to do is that when you draw all the points of this graph, what you need to do, you join them by straight line. So draw a straight line like this, draw a straight line like that, and maintain the seriality, sequential order in which we have plotted the points. Draw a straight line like that, draw a straight line like that, that in this manner. So you are going to get a picture like this. Often you have seen such kind of picture in newspaper. Okay, so probably you have thought ki how the pictures have been obtained. That is how the picture have been obtained. Okay, probably this look very familiar to you. So after getting all the pictures, you can do the same thing, similar thing for your R chart also. So you have to repeat the process. You have to repeat the process through R chart or for R chart. So I'm writing over here, repeat the same for R chart. Often in the example, often in the interview, companies interview wherever, it is often asked, it is often desired from the candidate that whether they know about statistical quality control or not. Statistical quality which control is thing which is going to stick with you as long as you work in a company. Okay. And when I was student, I mean when I was in my graduate course, I did practical. We have practicals in statistic, and statistical quality control is actually played a very vital role over there. One of the practicals we had to do was from statistical quality control. So many values are used to given were given to us, and we need to draw properly all the we have to plot all the points, and we have to calculate the quality control chart. We have to plot the quality control chart accordingly and analyze the situation. Okay, so it's also in statistic practical, this sort of problems are actually given to the students. So what will be the analysis of this kind of thing? What will be the analysis? Analysis from this curve would be, every statistical measurement is associated with an analysis. So suppose for the time being, suppose we have how many points have I drawn? 1, 2, 3, 4, 5, 6, 7, 8. Suppose, okay. So suppose, just for the sake of understanding, suppose we had actually 8 points. We had 8 points in total. Suppose points in total. And I have plotted all the 8 points over here. Okay. So from these 8 points, what have I seen? I have seen that 1, 2, let us number these points. Let us do it with a different color. This is my point number 1. This is point number 2. This is point number 3. Point number 4. Point number 5, 6, 7, 8. So we have seen that points falling within limits in X bar, points falling outside limits in X bar. What we have seen, that this value is how many points have fallen within limits? 1, 2, 3, 4, 5, 6, 7. 7 points in total have fallen outside limits, and only 1 point inside limit. Sorry, 7 points outside limit and only 1 point inside limit. Okay, and you have to mark those points which are outside the limit. So this is outside point, that is outside point, this is outside point, that is outside point. All these are outside the limits. You have to mark it, and you not only have to mark it in the uh, diagram, you have to mark it in the chart which you have prepared manually. I mean the table you are considering, you have to mark over there, because you have to see, you have to see which are these points which have fallen outside the limits. So for example, if I go back to my Excel sheet, let's see what happened, what is happening over there. The upper control limit is 6.46, the lower control limit is 6.11. Just remember that. So keeping this in mind, and if I talk about this quality control chart, if I this particular chart which was initially given to us, we see that this value, these values fall below limit, these values fall above limits, okay, these values this value again below limit, this value is again above limit, this value is again below limit, these two values, no, only this value, only this value. So in this way you can mark that which particular values are below limit and which particular values are above limit and which are in the limit. Okay, 6 point what was the value, 6.46. so no, 6.39 is within the limit, so you can mark it with a different color. Say for example, I'm using this color, that is within limit color. Okay, other colors are between limits, outside limits color. It may be below, it may be above, whatever. Okay, so in this way you can justify which colors represent what, and you can mark it over there. Okay, so in the question which I have given you, you are seeing that another part B is there. In the part B, it is mentioned that if necessary, revise the control limits computed in part A, assuming that any samples that plot outside the control limits can be eliminated. Now you see that if you are doing any statistical quality control for your company and you have got a chart where majority of the points are falling outside the control limits, then actually theoretically this particular scenario is very bad. That means your company is manufacturing items which are of low standard, and no company wants to project its company to the community showing that it is producing low category of items. So what you must do right now, in my last class I told you that there are two types of causes, that is called a chance cause and another is called assignable causes. Chance causes which cannot be uh, controlled, and assignable causes are those which can be controlled. Now assignable causes are of three types. One was you may have operator kind of problems, or you may have this product are defective. I mean, the raw materials for the products are defective, or maybe the system is not actually suitable. Machines are not working properly. So after seeing these particular things, after seeing this particular, uh, this particular quality control chart, you have to identify what is your actual cause of this type of, what is the actual cause. So you have to identify what is the actual cause of this type of, for this type of results, which assignable cause is actually affecting, or is it a chance cause or so, whatever. So for example, if the students who are coming out, who are actually being promoted to different semesters, and suppose if someone judges those students and regarding their knowledge of what they have learned in the previous semester during the lockdown situation, and if the students, majority of the students are not able to give the answer, then everybody will consider, because they know that the situation, that the problem was not with the students, the problem is with the lockdown situation, which was a chance cause, that wasn't that could not be controlled. Okay, but suppose everything is running very smoothly, but students are everything seems to be running very smoothly, and then students are not able to perform well wherever required, then you cannot blame the chance causes. Then you have to identify the assignable causes. Is the teacher bad, or is really the teacher, the student has low IQ, or is the college really good? So you have to identify that. Now in part B, suppose see, uh, that is your company's internal matter. I mean, before presenting, you're preparing a statistical quality control chart. You have prepared it, and before you are going to produce present it somewhere to someone, you have to, what do I do? We have to polish things. I mean, uh, when a movie is captured, then before it is being presented, it is presented to the audience in the movie theater, it is being edited, okay, many a times, once until the director is satisfied. So there are some versions which are called director's cut, there are some versions which are called final cut, like this. After that, the product which is left is being shown to us. Okay, same thing will happen over here. Before you produce this result in front of the higher authorities or the supervisor, then you have to analyze the situation, and you have to do some preliminary works on it, and you have to identify that is there any point which I can I mean I may not, I might not consider in the calculation. There are 25 values. Okay, is there any value which were not actually very much, I could have avoided that? So you will look for that. How to do that? So for example, in the question it is written that the copper content of a plating bath is measured 3 times per day. Now suppose consecutively for 25 days, the copper content were measured for 3 times. Okay. Now suppose the person who was responsible for measuring the copper content per day 3 times, he didn't want to work on Sunday shift. Okay. And because of that, he was very unhappy, because his supervisor actually pressurized him for doing works on Sunday. And therefore, what she Ohana, why are you so late to join? In the second session, you are joining. Why? In the first session, you were not there, Ohana. In second session, why have you joined? It's just for attendance. If it is just for attendance, then you can give your attendance, put it in the chat box, and then leave the classroom. And all, if you all can do so, because I am actually killing my time by making you understand, trying to make you understand the things. And in the first session you were absent, and now you are joining. It's not expected actually. What is the proper reason for doing this? Now what I was saying that so what I was saying that I mean this particular Now the person who was actually responsible for taking I mean these values, this sample. He didn't want to work in on Sundays, but the supervisor pressurized him to do so. So he took just values very casually, okay, and intentionally he has taken some defective items from over there from the sample. Okay, he may do so. So you can eliminate your Sunday measurements. You can eliminate all from all these 25 days. You have to, you know, that in on 20, if I 25 days means you are going to get at least 3 Sundays over there. Okay, so that those Sunday measurements can be eliminated from there. Now, first of all, before elimination, you have to check whether these Sunday measurements really, those Sunday measurements, those really fell in the limits or within the limits or outside the limits. Maybe this is your assumption, you know, you just assuming that the person who was responsible for sampling, he wasn't doing it properly on Sundays. So it is just your assumption. So before you just before you decide, you have to check whether it is really so. So is it falling within the limits or outside the limits? Now you probably have seen that for 4 Sundays, two Sundays were within the limits and 2 Sundays were outside the limits. So you just eliminate those 2 Sundays from outside the limits, and then you reshape your data accordingly. And then again, you calculate X bar, UCL and LCL, R bar, UCL and LCL. And then again, you draw your control chart and see what is happening over there. Now, in the question, they are saying that you don't have to do this much analysis because this problem has actually a problem. It has not been, the actual proper situation has not been shown in the question. So they are saying that on the basis of the assumption that samples that fall outside the control limits can be eliminated, what you are going to do is that you are going to, according to the question given in the part B, you are going to select all those points which are falling outside, the control limits, and keep only those which are within the limits. Okay, and you join them again by the lines. So they are just trying to telling you that you can manipulate in this particular way. In the question it is given. In the practical case, you cannot manipulate just arbitrarily. That is my advice to you. Now, people don't listen to advices. Now, if there is a pressure from higher authorities that you have to show good results always, then you are pressurized and you have to deal with that accordingly. So statistics is all about manipulation. I always say this word in my class. People actually don't believe me, but it is really so. But if you are a good statistician, you can manipulate in such a way that you can keep all the data properly, but nobody will get any hint of that. So that clever work can also be done. Okay. So I was saying that with all these values, you have to plot all the 25 values over there, and then probably I have shown out of 25 values, I have only shown 8. Maybe remaining values are falling within limits. So you have to check it. You have to draw the statistical quality control chart, and you have to repeat the same process. You have to draw another diagram for considering the R chart. Okay, and you have to see what is happening over there. So you can ask me one question, that if X bar chart is showing everything, what is the point in drawing the R chart? To suppose I'm going to explain that thing to you right now. Calculations can be done by anybody. You know, calculations these calculations are not tough calculations. The calculations can be done by anybody, but explanations cannot. People actually avoid explaining things, and therefore I am actually spending a considerable amount of time in explaining what is happening actually inside. So that is your X bar chart. That is your X bar chart, and that is your R bar chart. R chart, sorry, R chart. So you are going to get your X bar charts like this, or this, your X bar chart, and your R chart is going to have a form like this, or this, or this, your R bar chart like this. Okay. Now, why do I need those two charts? There are some softwares where R chart and X bar chart can be plotted side by side, and what people see, is that, let me draw an eye, that is you, and what people want to see is that they want to look at this X bar chart and that R bar chart, okay, together, and see if this fluctuates, how that fluctuates. So this simultaneous measurement, so two eyeballs are like this. I mean, I cannot show it. So the simultaneous these fluctuations are actually studied together. Because why? Why is it so? Because R bar talks about average, and R chart talks about it talks about central tendency, and it talks about dispersion. When we study statistics, when we start learning statistics, we come across these two words, measures of central tendency and measures of dispersion. Okay, and in the measure of central tendency, we actually consider mean, median, mode, etc. And in measures of dispersion, we take a range, standard deviation, mean deviation, etc. Okay, so initially we study all this. Now here actually we have considered this mean and range together. Okay, so we have to look at the fluctuations of dispersion, measure of dispersion, and measure of central tendency together to understand the thing in a better way. So therefore, if you are doing statistical quality control, and if you just draw the X bar chart, that will not work. I mean, if you are a presenter, if you are going to present your X bar chart only, that is incomplete. According to with respect to every X bar chart, there is always associated an R chart. With respect to, so let me write this point, with respect to every X bar chart, there is always associated an R chart. Sorry, a R chart. So keep this in mind. Okay, keep this in mind. Next, which I am going to talk about, is that sometimes, probably you have understood, okay, what I actually wanted to communicate with you. So in the next phase, I am going to talk about one particular formula. It is called X bar and S charts. Here S is actually the estimate of the standard deviation. Estimate of the standard deviation. So in the X bar R chart, what you did, you draw two diagrams, the statistical quality control limit for statistical quality control limits for X bar and statistical quality control limit for range. Here you are going to do the same thing. You are going to draw the statistical quality control for X bar and statistical quality control for standard deviation. So instead of considering the range, we actually consider the standard deviation. And the formula, if you are going to use this, the formulas will be given as follows. So for here in this case, X bar control chart. Remember the earlier formula which I have written, the X bar control chart was not just the formula for X bar control chart. It was the formula only when we use the pair X bar and R. But if you use the pair X bar and S, there will be a little change in the formula. So here we get the following. UCL becomes X bar bar plus 3 small S bar, or you can write capital S bar also. C4 is the tabulated value, and CL becomes your X bar bar, and LCL the same thing minus that. So 3 into S bar by C4 into root N. One thing, since I'm using all the caps, so let us use the cap over here. So capital S and capital S. What is capital S? Capital S bar is actually 1 by M summation I goes from 1 to N, 1 to M, SI, where SI is the standard deviation. Is the standard deviation, and you all know what is the formula of standard deviation. Standard deviation's formula is given to be like this. Usually we denote standard deviation by sigma. If I'm taking the standard deviation, if I'm considering standard deviations for each sample, sample 1, sample 2, sample 3, so therefore for all samples, the standard deviation formula is actually given by this summation xi minus x bar whole square root over. I explained that in my previous class. And if you are going to estimate this sigma, estimate of sigma, which is denoted by sigma cap, what we do, we divide by n minus 1, and we consider this summation 1 to n xi minus x bar, or if you want to write it in capital letters, so xi minus x bar whole square. The root over will be not here, sorry, here. That is your root. Here also this root will not be there. Standard deviation we all know. So that standard deviations will be calculated from all these standard deviations. S1 is a standard deviation, S2 is a standard deviation, Sn is the standard deviation. From all these standard deviations, the mean standard deviation will be calculated. So that is actually the mean standard deviation. Okay, and just like the previous page which I showed to you, we have to draw again 2 SQCs, that is for X bar, and here also we have to draw an SQC for SQC chart for S, and we are going to plot all the points in here. This is X bar and this is S, and all the points here like this, and the togetherness of these two things will be just studied, and accordingly we try to eliminate the assignable causes and chance assignable causes if there is any from our system, so that in the future we get better manufacturing products from the company. Okay, but if you can recall my last class, you will you'll find that you can remember that whatever you do with your system, whatever you try to uh, um, I mean rectify, every time if you take a random sample, there is expected at least 1 point which will fall outside the control limit. So that's why it's in our advertisement often it is shown, if you have seen that often it is shown that if you कीटाणु मारने का साबुन हम यूज करते हैं लेकिन हमेशा एक जार्म रह जाता है बॉडी में, हमेशा एक जार्म, कभी नहीं देखा 99.99% वी आर श्योर दैट इट वर्क्स, कभी नहीं कोई नहीं बोलता है कि वी आर 100% श्योर दैट इट वर्क्स. So if you do the random sample, if you take the random sample, we always expect at least 1 point which will fall outside the limit. Maybe it is above limit or maybe it is below limit. But if someone very beginning shows us a chart where every point is inside the limit, then actually we don't like it. We actually assume that probably something is wrong. He is manipulating. It has become a kind of habit with a surveyor. So if you want to do statistics, you do it diligently. So that completes our discussion of statistical quality control, which is there in, I am leaving these calculations for you to go through in the book and in the note. And I'm going to complete the discussion of statistical quality control with this part. X bar R chart, this X bar R pair, and this X bar S pair is there only. You don't have to do other things because the chapter is actually very huge and so many things are there. We are going to start another new topic in the next class. This is going to be my last session for today. In the next class, I am going to start the topic. Let me tell you in advance. The topic's name is, let me show you. That would be much better. In experimental design, I am going to show you this randomization in completely randomized and Latin square designs. Factorial design is there, crossover parallel design is there. I think that before I do this complete randomized and Latin square designs and factorial design, first of all, you have to know what is full factorial design, because you do not know completely what do you mean by completely randomized design. These definitions are not actually known to you. So you have to first of all know what do you mean by completely full factorial design or completely randomized design, like that. After that, we can come back again to experimental design, this section. Okay. So in the next class, I'm going to talk about one of the topics taken from module 3, which is design of experiments. Maybe I shall start with full factorial design. Okay. So I shall send you the note in advance in the Google Classroom, and on next Thursday, we're again going to meet and discuss on these topics. Hope you have understood what I actually tried to communicate with you. If you have any question, you can call me or you can leave it. Okay. So with this, I'm going to conclude my today's session. Thank you for joining. Bye.